Hey all, welcome back to Leka's vlog. I know many of you have been following our JEE exam revision series, and I am super happy to see your support. Today, we are continuing with more previous year questions to help you get even more confident for the JEE 2025 exam. As always, we'll go step by step, break down each answer, and make things super simple for you. So, keep your notebook ready and let's dive into today's set of questions. Yesterday continuation question today. The sixth question is temporary hotness in water is caused by the following pollutants. Take your time and think. Comment the correct answer. The correct answer is option A, bicarbonate of calcium and magnesium. Temporary hardness in water is mainly due to the presence of bicarbonates of calcium and magnesium. The formula CaHCO3 2 Mg HCO3 2. These compounds dissolve easily in water and can be removed by simple boiling, which precipitates the bicarbonates as insoluble carbonates. This type of hardness is called temporary because it does not persist after boiling. On the other hand, sulfates, chlorides, and nitrates of calcium and magnesium cause permanent hardness which cannot be removed by boiling alone. Let's move on the second question. If the swage contains grease and fatty oils, these are removed in. The correct answer is skimming tanks. Option C. Grease and fatty oils present in swage water are lighter than the water and tend to float on the surface. Skimming tanks are specially designed units where these floating substances are removed through surface skimming. This process ensures that such substances don't enter further treatment stages where they could cause clogging or interfere with the biological treatment. Grit chambers remove sand and grit. Sedimentation tanks settle heavier particles and detritus tanks are not suited for oil removal. We go with next question. Question number 8. Sludge volume index is defined as the ratio of. The correct answer is option A, percentage of sludge by volume to percentage of suspended solids by weight. Such volume index is a critical parameter in wastewater treatment, particularly in the activated sludge process. It measures the settling characteristics of sludge and is defined as the volume occupied by 1 gram of suspended soil after 30 minutes of settling in a 1 liter graduated cylinder. A lower sludge volume index indicates better settling ability, while a higher sludge volume index suggests bulking sludge, which is undesirable. The sludge volume index helps determine the efficiency of sludge compaction and clarifier performance. It is calculated using the formula Yes, VI equal to SVI means sludge volume index, settled sludge volume divided suspended solid into 1000. There I don't have a space, so I put thousands here. Okay. So this simplifies to the ratio of sludge volume to the suspended solids weight. It aids plants operators in controlling the return activated sludge rate and diagnosing process issues. Okay, let's move on the next question. Question number 9. Zero hardness of water is achieved by. The correct answer is option C, ion exchange method. The ion exchange method is most effective technique for achieving zero hardness in water. This process involves the replacement of calcium and magnesium ions. The primary causes of hardness with the sodium ions using a resin. As water passes through the ion exchange resin, the hardness causing ions are trapped and harmless sodium ions are released into the water. This method can remove both temporary and permanent hardness. Unlike the lime soda process, which typically reduces hardness but does not eliminate it completely. Excess lime treatment is effective for partial hardness removal, and alum dosage is mainly used for coagulation in water treatment, not for hardness removal. Thus, only the sorry. Thus, only the ion exchange method guarantees soft water with a hardness, making it ideal for boiler feed and laboratory use. Question number 10. A sample of swage is estimated to have a 5-day 20 degrees Celsius BOD of 250 milligram if the test temperature be 30 degrees Celsius. In how many days will the same value of BOD will be obtained? Let's solve the problem. BOD means biochemical oxygen demand. It is the amount of oxygen needed by microbes to break down organic matter in water. To solve this problem, we use the first order BOD equation, which relates BOD extended at different times and temperatures. The basic formula is BOD T equal to L into 1 minus e power k into t. Where BOD T is the BOD extended at time. T is for time. So L is the ultimate BOD. So K is the BOD rate constant and T is the time in days. But here, instead of solving this using both L and BODT, we use a simplified approach based on temperature correction for reaction rate using the Van 't Arrhenius equation. So K2 equal to K1 theta power T2 minus T1, where K1 is the rate constant at 20 degree, K2 is rate constant at 30 degree, and theta is the temperature coefficient. So commonly we use 1.047 for switch. Now since the BOD of 250 milligram is the same at both temperature, we equate the equations and find the time at 30 degree denoted as T2. The relationship between time and rate constant is K1 into T1 equal to K2 into T2. So T2 equal to K1 into T1 divided K2. So substituting K2 from the temperature correction gives T2 equal to T1 divided theta power T2 minus T1. Putting values, T1 5 days, theta 1.047 and T2 minus T1 equal to 10 degree. We get T2 equal to 5 divided 1.047 power 10 approximately. So the answer is 3.3 days. This means at 30 degree the same 250 milligram BOD will be extended in just 3.3 days. Hence the correct option is 3.3 days. In short, theta adjusts how fast the reaction happens with the temperature, and the exponential terms shows how significantly the reaction rate speed up as temperature increases. Thanks for watching. If you found this useful, don't forget to like, share and subscribe to Leka's blog for more smart and simple exam solution. See you in the next video. Bye-bye.